Next up, video 3. Now, videos, I believe 4 and 5 are going to be more about the other two types of chi-square tests I mentioned. The first type was our goodness of fit test. Before we get into those two other tests, we need to discuss how to calculate expected counts for a different type of chi-squared problem. So in the last section, the chi-square goodness of fit test worked with one categorical variable, which had multiple parts to it. So if you think about the M&Ms, our one categorical variable was color, and we had multiple colors, and the probability for each of those parts. So in the M&M problem, blues were expected to come up a certain percent of the time, reds a certain percent, browns a certain percent, etc. We wanted to test if each part of a categorical variable of interest met some hypothesized value. We calculated expected counts for each of those parts, and in conjunction with the observed counts, calculated the chi-square test statistic to then calculate a p-value. So what happens when we have more than one categorical variable? We will now shift our thoughts to two more types of chi-square tests soon. So here is, now this will work, getting these expected counts for more than one categorical variable. This will apply to our last two tests. So it's not like you're going to have to know how to do expected counts 3 different ways. There's really going to be one way for goodness of fit tests and a second way for the last two types of chi-square tests. In a study of the television viewing habits of children, a developmental psychologist selects a random sample of 300 first graders, 100 boys and 200 girls. Each child is asked which of the following TV programs they like best: The Lone Ranger, Sesame Street, or The Simpsons. Results are shown in the contingency table below. Now, this is an example I pulled out of the book. I'm wondering, is there some new version of The Lone Ranger I'm unaware of here? Because I thought that was like something my grandparents, maybe my parents watched, if they're that old. Sesame Street kind of seems like it's pretty babyish, and Simpsons, I mean, how many first graders are really watching The Simpsons here? That's not really a show I would let a first grader watch. I don't know. Anyway, that's a whole other story. Before we answer the question, do the boys' preferences for these TV programs differ significantly from the girls' preferences? We need to discuss how to calculate expected counts for each of the 6 observed counts. So here are our 6 observed counts. How many boys and girls liked watching The Lone Ranger, Sesame Street, and The Simpsons separately? Okay. So to get our expected counts here, what if the boys' preference did not significantly differ from the girls' preferences? Okay, so that's going to kind of be like our null hypothesis, if you will. What if the preferences were really the same? So let's start with the boys. There's a 100 out of 300 probability of selecting a boy, right? We have 100 boys. We have 300 kids total. We basically have a 1 in 3 chance of selecting a boy. Okay, so if the show did not matter, then we would expect 1/3 of the 100 total Lone Ranger viewers to be boys. That makes sense? Again, let me say that again. We have a 1 in 3 or a 100 in 300 chance of selecting a boy. If the show did not matter, if it doesn't really matter which of the 3 shows they would pick, we would expect 1/3 of the 100 boys to like the Lone Ranger. So 33.33. Okay, so think about this number right here. We would expect out of 100 boys, out of 100 boys here, 1/3 of them, because there are 1/3 total here, to like the Lone Ranger. We would expect 1/3 of the 110 Sesame Street viewers to be boys. So 1/3 of 110 makes 36.67. Lastly, we would expect 1/3 of the 90 Sesame Street viewers to be boys. So 1/3 of 90 makes 30. Now, do we have to use this same type of logic for the girls? And the simple answer would be no, we wouldn't, because we only have 2 things here. If 30 boys like The Simpsons and there's 90 total kids, well, that means the other 60 have to be girls. And in the 110 case, this would have to be, oh, what? That'd have to be not a 23, a 33. That would need to be a 3, and this would need to be a 7, 73.33, I believe, plus that makes 110. And this would need to be 66.67, plus 33.33 makes 100. And if we added up these three numbers, we should get 200 girls total. So again, it's exactly what I just said there. Let's just reveal those numbers. There we go. Now, if you didn't notice what I was really doing there, here is a way that you can get those numbers easily. Just apply this pattern. What we were really doing was taking the row total times the column total divided by what I called the total. So let me jump back here. Let's clear this off. Now let's go all the way back here. So if I wanted to figure out the expected count, how many boys would I expect to watch The Lone Ranger? To get this number, I need to go to my row total, which is the 100, multiply it by my column total, and then divide it by the total. So really this would be 100 times 100 divided by 300. And guess what that comes out to be? 33.33. If I wanted to figure out this value, what are the expected number of girls for watching The Simpsons? Well, row total, column total, total. I need to take 200 times 90 divided by 300. And that should give me 60. So that's all I'm really doing here. Row total times column total divided by total. Okay, and here's your total there. So if what I tried to explain really didn't make much sense, you can just apply this simple formula. Here is the problem that I would like you to do and bring to class. I will check it for homework. All you need to do here is calculate the expected counts for each of the 6 observed counts above. Okay, this is how many we saw here, and here. And I want you to use the information. You might need to get some totals here, like row totals, perhaps. I already gave you column totals. You're welcome. And you might want to figure out what is a total. So come to class tomorrow with basically a new table that has 6 expected counts for these 6 observed counts that we can compare them to. And that is all. No, don't see that. No, wait. Yeah, make it look like this, basically. Just fill out what are these numbers now. Go from there. Good luck.